angles on a circle. But we've done a lot of angles. We've done some circle stuff. So most of this, I think you'll be familiar with. So I think we're just going to work some problems together here. Let's draw these angles. On a circle. And we'll just put 4 angles all at once and we'll put them on the same circle. So 105 degrees, negative 160 degrees, pi over 4, and negative 2 pi over 3. So let's draw a circle. Don't draw it too small because we're going to put all 4 on one circle rather than draw 4 different coordinate planes. So probably one medium-sized one is better than 4 smaller-sized ones. And I think maybe you could put these on there, especially the degree ones, but I'm going to go ahead and label it kind of like we did yesterday with degrees. So 0 and 360. Halfway around is 180. Half of that is 90. Halfway in between is 270. Most of y'all are pretty good with those because we're more familiar with degrees. Let's do it in radians as well. So 0. What's all the way around in radians? 2 pi. And if you can remember that much, you can figure out the rest. You don't have to have everything memorized. If you know a little bit, you can figure out the rest. Halfway in between 0 and 2 pi would be pi. Halfway between 0 and pi would be pi over 2. And then the one that takes a little bit of thought, what's halfway between pi and 2 pi? 3 pi over 2, or 1.5 pi. We always write it as 3 pi over 2. I had a student in 7th period just begging to write it as 1.5 pi. And that's not wrong, so if that makes you feel good, do it. But everywhere else you see it, it's going to be written as 3 pi over 2. All right, so let's put these angles on there. 105 degrees. Remember, we always measure from the positive x-axis rotating up, unless it's negative, and then we rotate down. So 105 is bigger than 90, less than 180, closer to 90. So as best you can, go 15 past 90. Again, I don't need you to have a name blank, the protractor, thank you. The protractor, just get it a little bit past 90. So I'm going to say that right there is 105 degrees. Again, if I used a protractor, would it be 105? I don't know, it might be 100 or 110 or something, but close enough. All right, negative 160. So negative means I got to go backwards. And it also means I have to be real careful about these numbers, because when I reach this first marker, that's not really 270 now. That means I've gone 90. So that's backwards 90. That's backwards 180. So I don't want to get all the way to 180. I want to be a little bit short of that. 20 degrees short of it, to be exact. So there's negative 160. Again, no protractor, just landed in the right quadrant, closest to the right quadrantal. That's the fancy word for those, the axes. All right, pi over 4. Okay, so now my brain has to kind of switch into radian mode. Pi over 4, that's 1/4. So up from 0. Am I going to pass pi over 2 or not get to pi over 2? Yeah, not get there. 1/4 is less than a half. In fact, it's exactly half of a half. So pi over 4 will be right in the middle. And then lastly, negative 2 pi over 3. So negative means I need to go backwards. need to be careful now. If I'm going backwards, this is negative pi over 2. So I need to pass that. 2/3 is bigger than 1/2. But I don't want to get all the way to pi because 2/3 is less than pi. So I need to go past pi over 2. And let's see, 2/3 is closer to 1/2 than it is to 1. A little bit of fraction sense here, right? 2/3 of $1 is 0.67. That's closer to 1/2. So again, it doesn't need to be perfect, but it does need to be in the right quadrant, closest to the right angle. So negative 2 pi over 3. So not hard, but go slow. Make sure you land them in the right spot. Now, we hadn't used a word yet that we're kind of approaching on, and that is this idea that you can get to negative 160 multiple different ways, right? You could go the other way. What would that be? That'd be 200 to go 180 and then 20 more. So there's more than one way to get to each spot on the unit circle. There's different ways to land in the same place. And the fancy name for that is coterminal angles. And the not quite fancy definition is angles that land in the same spot or in the same place. This is the only new thing we're adding today, this idea of coterminal angles. There's more than one way to get to each spot on the circle. And to find extra ways to get there, we'll add or subtract 360 degrees. Because wherever you are, if you spin around 360 degrees, you're still in the same spot. If you spin around backwards 360 degrees, you're still in the same spot. So you can add 360 as many times as you like, and you still land in the same spot. So you can add 360, and then 360, and then 360, and then 360. And I think that means we spun around 4 times, but we'd still be in the same place. And then the same could be said for 2 pi if we're talking radians. Because if you spin around 2 pi, you're in the same spot. So you can add or subtract 360 or 2 pi as often as you like. So some of these questions will have an infinite number of answers. Like find an angle that's coterminal with negative 160. Well, there's an infinite number of angles that are coterminal with negative 160 because you can just keep spinning around as many times as you want to write out answers. So a lot of times we'll ask to find 3 coterminal angles or find a coterminal angle, a specific one. That way you don't sit there and write all day long. All right, let's find 3 coterminal angles with we'll do this once in degrees and once in radians. 3 coterminal angles with 20 degrees. For some people it helps to draw it out. For other people they don't matter. They just add 360 3 times and that's fine. So you don't have to draw it, but if it helps you kind of get a picture of what's going on, there's 20 degrees. And if I spin around another 360 on that, I would get to 380. So there's one of my answers, 380 degrees. And then if I spun around another 360 degrees, let's see, that would be 740. I could spin around another 360 degrees, or I could back up one, so just to show the minus, I'll do 20 minus 360 degrees. And that would be negative 340. So that would be starting here, going backwards all the way around. But all of those land at the same spot, so they are co, meaning same, terminal, meaning ending, like the airport terminal is where your flight ends. So same ending, literally what coterminal means. All right, let's do one with 5 pi over 6. So exact same thought process, a little bit harder because we're not familiar with radians. We don't like adding 2 pi and subtracting 2 pi, but it's the same thing. Let's see, 5 pi over 6 would be not quite the pi. So right there. It didn't ask us to draw it, but that helps sometimes. So let's add 2 pi, because that would be a full spin. And then now we get to see who remembers how to add fractions. So what do I need to add fractions? Common denominator. So multiply top and the bottom by 6. So 17 pi over 6 is one of my answers. So I'll add 2 pi again, but I've already converted it into over 6, my common denominator, so I'll just add 12 pi over 6 again. So that would get me to 29 pi over 6. And then I could add 2 pi again, or I could come back here and subtract 12 pi over 6 and get negative 7 pi over 6. Again, there's an infinite number of answers. You could add 3 times, you could subtract 3 times. I suppose you could add 2 pi 4, 5, and 6 times and get your 3 answers that way. Nobody would do that. But there's an infinite number of answers. Monica?
On the test for these type of questions, if we don't put degree or like rad or like units, will we get points off for the answers? Or?
Okay, so the question is, what about the units? Radians is a tricky unit because it's kind of a non-unit. Like when you need it to be there, you can write radians, but because it is not really a unit, if you don't write it, it's also okay. So it's kind of weird.
Does that affect the degrees?
Now degrees, you need to put degrees, okay. But radians, you can fudge either way. Number 3. Let's find an angle between 0 and 360, coterminal with say 853 degrees. So somebody's been doing a lot of spinning. We want to know, well, okay, that's great, but like really where did you land between 0 and 360? What's the coterminal angle with that? So what do I do to find a coterminal angle? Subtract 360. And I'm going to switch to a calculator here since we got funny numbers going on. 853 minus 360. 493, is that my answer? No, what do I need to do then? Subtract 360. 133, is that my answer? Yeah, it's between 0 and 360. So 493, 853, and 133 are all coterminal, but we wanted the one between 0 and 360. This is how we'll usually write the problems for 2 reasons. Selfishly, it makes it easier to grade because everyone's going to have the same answer, right? If I leave it open-ended, then there's an infinite number of answers out there, and I don't really want... Most of you are going to pick simple ones, but there's always 1 or 2 people who get creative and add 360 10 times with the calculator and then write that down, and then I got to figure out if that's really it or not. So to avoid that, we can specify. It's also helpful in the coming weeks. This is mostly what we'll be doing, is taking an angle that's too big or too small and getting it to a sort of a regular angle between 0 and 360. All right, how about a coterminal angle with negative 1037? How in the world am I going to do that? Let's add 360. Right? I could subtract 360 and get a coterminal angle, but I'd be heading in the wrong direction. So negative 1037 plus 360 is not what I want. Well, I mean, I'm on the road here, so let's add 360 again. Oh, getting close. Negative 317 plus 360 one more time is 43. So coterminal means add or subtract 360 as many times as you need to or want to, kind of depending on the question. Or 2 pi. Let's do one more type of question. Well, I guess it's the same type question, it's just with radians. Find an angle between 0 and 2 pi, coterminal with, so same type question, except now we're in radians. And so it just forces our brain to work a little harder because of the fractions. So 16 pi over 3. That's bigger than 2, whatever it is. So what should I do to start to get an angle that's between 0 and 2 pi? Subtract 2 pi. I mean, it is subtracting 360, but I need to subtract it in radians. So let's subtract 2 pi. If you're good enough to do it on the fly, that's 6 over 3. So that would be 10 pi over 3. And here's where our fraction sense comes in. Is 10 pi over 3 in between 0 and 2 pi? Yeah, some hesitant head shakes, but mostly head shakes. Because 10 divided by 3 is 3 and something. So we're not there yet. Let's subtract 2 pi again. 10 minus 6 is 4. 4 pi over 3. Is that between 0 and 2 pi? Yeah, because 4 over 3 is a little bit bigger than 1, but not quite 2. So there's the answer we're looking for. Last one. Negative 47 pi over 9. Well, it's negative, so it's definitely not between 0 and 2. It's negative, so I don't want to be subtracting 2 pi, because that would send me more negative. So let's add 2 pi. Somebody want to save me a step? What's 2 pi in terms of over 9? 18 over 9. Maybe you want a calculator for that. Negative 47 plus 18. Negative 29. Still not okay. I guess this one's easier to know when you get there because you won't be negative anymore. So we'll add 18 again. Negative 11 pi over 9. Still not there, but that's okay. This is an easy problem. Just keep adding 2 pi until we get there. Negative 11 plus 18 would be 7. 7 pi over 9. That's between 0 and 2 pi, so we're good. All right, today's assignment is Unit 8, Worksheet 4. I'll give you the review worksheet. Officially, it's Monday's assignment. If you guys online, I'll post it so you can get started if you want to. I'll also post answers to Worksheet 4. I don't have the answers to the review worksheet yet, but again, that's not due. It's all due Tuesday on test day. And again, you'll get the review today, but that's up to you on how you want to use your time to complete that and be ready for the test on Tuesday.
Are we finishing worksheet 2?
No, we are not going to finish worksheet 2. So we stopped at 20, I think, and we're good there. Good question.